Welcome to Defin episode number 45. Today, hey, welcome Moe Aboulkheir.
Yeah, Aboulkheir.
Aboulkheir.
Your guess is as good as mine.
Okay, I was trying to pronounce it, but I think Moe is the easiest thing to say. So
yeah, it's not even my real first name. It's just a lot easier to say.
Yeah, you're doing like what VJ and all the Indians do. You're making concessions to
to Western
the English
people.
idiots. Yeah.
In my defense, it was decided before I could speak. My parents just gave me this very ethnic name, and I was born with blonde hair and quite light eyes, and it just didn't play. It wasn't going to sell.
But I mean, you could argue that my name is ethnic. It just happens to be white ethnic. So
yeah,
of course I win. So there we are. But so what's more short for then?
Salah.
Salah.
Yeah.
How is more short for Salah, or is it Mo Salah?
So the family mythology is that there was I think there was a female tennis player called Little Mo.
Oh yeah.
And I don't know what she has to do with me, but my parents just.
I think she was wearing the same cardigan as you were. Yeah.
Probably something quite similar if she was a tennis player.
Yeah, that's what I'm thinking.
So yeah, I think they just figured I looked a bit more like a Little Mo than a Salah,
Okay.
And I agree with them.
But I must say, like you're the most well-dressed guest we ever had. So I think the people who are listening to the audio probably can't see, obviously. But yeah, this is like first time ever we have like super well-dressed guest on the podcast.
Well, if the content is a disappointment, at least we'll have that.
Yeah. And also the sort of the David Lynchian style curtain in the background, to give the extra spooky effect for the YouTube video. I mean, this time it's really worth paying that Patreon cash, guys, to get access to this YouTube video.
I encourage it. I was going for some kind of eldritch luxury. Was the kind.
The final throes of disaster capitalism.
Right, yeah. It's like a Hammer horror movie. Background.
I think the Hammer horror movie is very on brand for us, actually. Yeah.
Yeah?
Oh, yeah.
I have no idea what you're talking about.
I'm down with that, like the Abominable Dr. Phibes or whatever.
Yeah.
Was it Dr. Phoebes? I forget.
Like cheap horror movies, basically, that aren't really scary. But
okay.
Anyway, yeah, carry on. Yes.
Yes. So we'll get back to the cheap horror movies later, I think. So Mo, again, welcome to the show. Can you give us a bit of introduction about your work? Your work in Clojure. How did you come into Clojure?
Yeah. So I've been writing software since I was 12 or so.
Was this after you gave up tennis or before that?
I was actually playing tennis at around the same time, but reluctantly. And I've got a very funny story about that I couldn't possibly tell on a record thing. But
it's okay. Nobody listens to our podcast.
So I just because I was a loser and there was a computer in the house, right? So I decided to figure out how it worked. I wasn't the sort of best behaved adolescent, so I kind of left school early, and was faced with the prospect of either living with my parents or deceiving some startup into paying me money, and I went with option 2. That was when I was 17, I think just before I turned 18.
And then the internet died.
And I'm now, I turned 34 yesterday.
Oh, happy birthday.
Thank you. Thanks. So since then, it's mostly been, uninterrupted software development in a conspicuous number of languages, paradigms, operating systems, business domains, online casinos, investment banks.
Is there a difference more?
Yeah,
Really?
it's like putting them in the same.
I don't think of them as different domains, but I've worked in both myself, so.
I think the dress code is perhaps the most salient difference. But
Yeah.
I was going to make the joke if you didn't.
Okay.
And then a bunch of sort of open source consultancy. Started my own after a bit, and currently work for Samsung in sort of VR and AR stuff. So mostly around high performance kind of pipelines for processing, transforming videos. And I first got into Lisp, I guess, a long time ago, maybe when I was 18 or 19. I was a kind of closet scheme developer for years,
Right,
and I had no idea. I mean, I could never have imagined that circumstances would evolve in a way that would allow me to get paid for, bashing out the parentheses. And I kind of got into Clojure a little bit late because, I read some of the docs, and I wasn't, overly enamored with the JVM at that time, although that's but my opinion of it has improved. I just didn't have a huge amount of experience with it, and the interrupt kind of put me off. So I didn't really sort of get the the kind of maximum leverage approach that typifies a lot of the decisions that guide Clojure's development. So I've got a terrible subjective sense of the passage of time, but I would say the last 4 or 5 years, I've mostly been writing Clojure, but I've also been a C programmer, a Python programmer, GLSL shaders, F#, C#, the whole deal.
So how do you compare Clojure to those things? Because you had experience with Scheme already, and then with all these languages?
Yeah. So, I mean, with Scheme specifically, I think it makes sense to look at Scheme as a kind of construction kit for programming languages. Like it doesn't include any features that are extraneous beyond what you would need to implement an extraordinarily powerful runtime. I think its downfall is that it didn't really take a firm stance on packaging systems. So they had, there is they do have a kind of a proposal amendment process, the SRFI, or I think some people pronounce it phonetically, like not phonetically, but SRFI or whatever.
Yeah.
For advancing the standards. But if you look at the kind of landscape of Scheme implementations, it's very much not write once, run anywhere.
It's very hard to share the code, basically.
Yeah, absolutely. Everyone's got their own prelude that will kind of coerce the code into running on their pet 2 or 3 top scheme. I mostly worked with Chicken Scheme. My claim to fame is participating in the logo design. I think it's got a pretty neat logo, but yeah, that was so yeah. In terms of comparing Clojure to that stuff, I mean, Clojure strengths I think are in its the abstractive powers that it confers on developers, and I think those are truly unparalleled in any of the programming languages I've used in any depth. Certainly Scheme has the lambda is the universal abstraction, and cons cells are used to inefficiently implement all manner of data structures. I think yeah. So I firmly believe that Clojure is the best Lisp. It's not some the best Lisp that's existed. It's not a kind of compromise or a Lisp that's easy to pitch to management because it runs on the JVM. I think it's immaculately well designed and well considered.
Do you think it's the functional aspect of it? Because obviously with Scheme you've got various options. With Lisp in general, you've got lots of options, lots of paradigms you can choose from. But with Clojure, essentially, it was a functional beginning. I know that you can do other bits and pieces with it. Everything can be imperative to some extent. But is that what you would like? Am I playing that back to you correctly?
Yeah, I would say more the different options you have for kind of runtime polymorphism. I think I didn't have as big a problem as I think others did with kind of purity or immutability by convention in Lisps that did permit it. But yeah, I also never really wrote a substantially sized system in Scheme. So, I'm sure that stuff becomes a problem when you're incorporating multiple libraries, all with different approaches to doing things. But yeah, I think, stuff like, multi-methods, protocols, keyword hierarchies, even really simple things like namespaced keywords. I think those things are incredibly powerful features. That just give us options. Particularly protocols, I think.
But compared to, because there is this discussion around refactorability, if there is a word, of a large code basis, if you use like a statically typed programming language, because you said you were also familiar with, or at least did some projects in F#. So how do you see the contrast between these two then?
So I don't like statically typed programming languages personally. Like I have a grudge against them.
Why?
Welcome to the show.
I just don't like the compiler taking that tone of voice with me. Like I don't know if either of you have tried to write a program in Rust.
Yeah, I did. Yeah,
but it's like going through customs in like a country that's at war. I always gravitated towards dynamically typed programming languages. Yeah, refactorability is a problem, but like with anything, I mean, types only get you so far. And so, some of this hyperbole you see from the static typing advocates, I've heard it claimed that we're morally deficient, and
well, I think we own the morally deficient podcast space, so it's okay. Yeah.
No, I'm certainly no paragon of moral virtue myself, but I wouldn't ascribe much of that to my use of dynamic typing.
No,
but
good to hear.
I think. Yeah, so I can be productive in statically typed environments. I think in terms of languages that have achieved some kind of traction in industry, I would say, C# is a relatively comfortable language to work in, far more so than Java. Setting the runtime differences aside. And then, I've done some messing around in, SML and OCaml, and I found that stuff interesting, but it didn't. And Haskell as well, to a lesser extent. But I just didn't feel like I was getting the superpowers that people were telling me I was going to get.
Yeah. So I think this is a nice comparison, because we usually hear having a compiler or statically typed languages is that they're going to help you in terms of writing your program and guiding you through the stuff. But I think we're going to settle for it's going through the customs through a country that is in a war zone or something.
Yeah, absolutely. Can I see your papers?
Yeah. So you said you started using Clojure almost 4 or 5 years ago, and
I think so. Yeah.
And you have a couple of open source libraries that you already built. Do you want to give us some idea about what they are?
Yeah, I think the most popular one is the unimaginatively named CLJS Lambda, which is it's a collection of projects, a runtime library, and a Leiningen plugin, and also a piece for integrating with serverless. That allows ClojureScript functions to be deployed to AWS Lambda, which is their offering for precisely metered sort of deployable functions. The kind of premise being that even with AOT compilation, at least at the time that I was writing the library, it just didn't make sense to use Clojure because the startup times were unacceptable, and it's difficult to predict whether a particular invocation is going to reuse the resources from a previous invocation, or if it's going to restart a fresh one. I mean, I've seen people do crazy things like write functions that repeatedly invoke their function to ensure that it's always kind of hot. But
it's sort of not the point of serverless then,
No, yeah, totally not. I'm
going to build a management infrastructure around the serverless environment. Stop right now, please.
Right. I think serverless is great, and I initially wrote a Leiningen plugin that does all of the AWS stuff in terms of creating the functions, merging their configurations, uploading the zip files. But I would strongly recommend anyone who's interested in that ClojureScript on Lambda library to use it via serverless. There's just a serverless CLJS plugin that you can add, and it'll just create a zip file via the ClojureScript compiler interface. And there's an option to use. I'll forget about it because I forget even what the name of the compiler is. But there's some non-JVM compilation option. So that, and then more recently there was a project called Sputter, which is a partial implementation of the Ethereum virtual machine. It doesn't do everything, and I'm not interested in making it do everything, because what was mostly fun about writing it, aside from learning about the EVM and the the decisions that went into its development, some good, some not so good. It was that it was the first project I'd worked in a long time that wasn't principally focused with I/O, and it turns out that it's really fun to write programs that are kind of self-contained and are mostly translating data So stuff like writing compilers and so on.
So before you get a bit deeper into that one, can you give us some idea about Ethereum and EVM? What it is, and whether we can make money like everybody is jumping onto that shit right now?
Yeah, I certainly I'm not the person you should ask about how to make money in that space.
Yeah.
But Ethereum is a project. It was started by a gentleman goes by the name of Vitalik Buterin or Buterin. It's considered the sort of regardless of where it is in the market cap rankings versus Ripple on any given day, considered to be it certainly has the greatest amount of developer mind share of any of the blockchains. And its distinguishing feature is that it allows, in practice, it's not Turing complete because there is a fixed cost to each instruction, but assuming an unlimited budget, you can execute unbounded programs, deterministic unbounded programs that are written in higher level languages that are then compiled down to EVM, the Ethereum Virtual Machine bytecode. I think they very much follow the DIY aesthetic. I would say that none of the higher level languages are particularly well defined. Particularly well designed, rather. I would say so some of them are sort of actively catastrophic. And I think there were some awkward decisions made in the design of the virtual machine itself, but it is interesting, and I think the kind of
we can dive a bit more into that more actually. So just tell us a little bit about what you think about like where those issues are, because I think obviously there has been a big discussion around the fork of Ethereum because of the fuck up on the contract. They're claiming it was not a problem with Ethereum; it was just a coding error. So you seem to be suggesting there's something deeper there.
So I didn't have that DAO hack in mind specifically, but I think that kind of reentrancy probably should be inexpressible, in a language that's designed for financial computing. I would say I have some low-level quibbles with the EVM, the design that probably aren't worth delving into in too much detail. Like the native word size is 256 bits. So even if you're if you want to twiddle a single bit, you're paying the cost of the other 255 that you don't care about. Despite the fact that in modern programming languages, it's trivial to represent variable width integers. In terms of the higher level languages, I think clearly Solidity is the language with the greatest. The greatest number of contracts have been written in Solidity. It's from my perspective, it's a catastrophe from the perspective of programming language design. I think the kind of guiding architectural principle was let's make it look as much like JavaScript as possible, but of course it's doing things that are very different to JavaScript. But I would say my critique in general would be that clearly Vitalik's inspiration for all this were Nick Szabo's early essays on smart contracts, and the idea that we could have deterministic executable financial instruments. We could represent title deeds, dividends, all derivatives, all manner of complex instruments. And I think that term smart contract has a lot to answer for, and so so does ledger. I mean, yeah, the legal contracts, they're sequential. They're often, but I would argue that they're more sort of declarative than imperative. And I've read through a lot more. I've read through a lot of Solidity contracts, and my impression is that they're not really executing. They're not really performing logical operations. They're brokering access to data that is ridiculously expensive to store. So my fundamental contention would be that if Ethereum is actually a database, and it's a very badly designed one, and I would say the same even about Bitcoin. I mean, we use this word ledger, and I think that's kind of determined the way we think about these things. I mean, a ledger is just a special case of a database with a particular disposition towards the semantics of the values it's storing. So I'm interested in looking at blockchains from the perspective of information systems. So read through any Solidity auction contract, an escrow contract. All the methods are doing brokering access to pieces of data that could just as well be exposed directly if there were a general means for doing so, and a means for declaratively expressing access controls.
So before we get on to I take your point. In terms of logical comparisons, would you say, because one of the things that they say about the thing that I hear about ledgers is that, from a closure perspective at least, is that they're a bit like Datomic in the sense that they're like time as a first-class citizen. They keep all their old records, and so you can history is built in, and that seems like a good thing. So there's some advantages around that. But obviously, the smart contracts are more about, let's say, trust issues and trustlessness rather than the semantics or the behavior of a particular time series in a database.
Yeah. So one point I'd like to make around that is that while certainly a lot of these networks can be described as immutable databases, vaguely similar to Datomic, in their programming models, the history that all this computational effort and organization and in some cases power consumption has been devoted into maintaining is completely discarded. I mean, a Solidity contract doesn't have access to any value at any preceding block height except the one at which it's being invoked, unless it specifically made the effort to persist those values in data structures. But the only data structures that are available, completely immune to any kind of structured querying or and they're ridiculously expensive, right? I mean, obviously it fluctuates with the gas price, but I checked a couple of months ago, and the price per gigabyte for data storage on Ethereum, it's in the millions, the tens of millions of dollars, I believe. Wow. I think it would have fallen, propitiously since then, but it's still completely unaffordable. So and I think Datomic is interesting because it's saying, hey, immutability is great, not just as a kind of means of attaining auditability, but also if we embrace it in our programming models, it gives us superpowers like the ability to time travel, the ability to compare databases at different times, or with with different sets of transactions applied to them. It's astonishing to me that blockchains put so much effort into maintaining an exhaustive history of every possible state, and then they just drop it on the floor as soon as any code is being run.
Yeah, I mean, obviously it's not dropped in a persistent state, but yeah, I take your point. But one of the other things that people talk about, though, is the like I said, the trust aspect of it, which is the more tricky part. Whereas if you're in a kind of environment where your administrators can make all kinds of changes to the database, potentially they can subvert the data. Isn't that the biggest value, if you like, of the Bitcoins and the Ethereums, in the sense that there has to be a very large quorum that it's almost impossible to game in order to modify the data?
Yeah, I think so. But, I mean, Amazon have filed patents for, and I'm sure I have engineering teams working on implementing those patents that will offer all of the guarantees of these public blockchains, just without the counterparty risk of having all of the nodes, located on a kind of homogeneous network. And I would argue that that's a risk that would come across as extremely eccentric if it were expressed in a boardroom. So, I think if this stuff, attains any kind of mind share, for the majority of use cases, Amazon is just going to eat everyone's lunch. I mean, you could get that, recursive cryptographic hashing, and get all that good, tamper evident, good stuff without having to run a public network. I think that's what's going to happen. I mean, I think these public blockchains exist both at the mercy of or at the caprice of regulatory agencies and at cloud providers. I mean, their cloud providers have unprecedented levels of infrastructural centralization that would result in throughput that would require a really powerful kind of counter argument to a business adopter, in order to turn away from.
So you don't think that the end of kind of like cloud providers as a monopoly is imminent then?
No, I heard some rhetoric in that question, but no, these guys employ armies of astonishingly talented people, and they could outcompete the development teams, on everything except just one or two line items of trustlessness that businesses gave up a long time ago and aren't gonna, I don't see ever caring about. So I mean, but that said, I do think there are cases where you do want to pay that cost. The cost boasted, but the kind of throughput cost of running on heterogeneous networks, outside of cloud providers. And obviously, while it's I'm sure in practice impossible to trustlessly prove the kind of geographic distribution of a valid data set or whatever in a given network. I think there are or it's not maybe an awkward word to bring into the discussion. I think there are sort of commons-oriented projects that could justify paying that price, where it just wouldn't make sense to run something so ambitious and with such a long, kind of long time horizon on AWS. And the stuff I was saying before, wasn't necessarily a defense of the cloud providers. I mean, I think that there's some really unpleasant asymmetries in the relationship between cloud providers and their customers. You can throw hundreds of millions of dollars at AWS, potentially even per month, for a Fortune 50 company, and that doesn't buy you any foresight into their plans to end of life software that you're depending on, or to prioritize the features. There may be a champagne room that I don't know about, but I've certainly worked in companies that racked up substantial bills, and it mostly just got us prioritized support access.
Well, didn't Samsung in the end just buy their own cloud company? They bought Joyent, didn't they?
Yes, yes.
Because I guess they couldn't get that champagne room access. They just figured, okay, screw it, we'll just buy something that's essentially, will give us control.
I think instead of buying software, you just buy software companies, and then instead of buying, getting into cloud, just buy a cloud provider and just be done with it. I think in the long run, it's probably cheaper, I think.
It's I guess it's just rewinding to running your own data centers.
At a certain scale, that's what it kind of feels like. So just getting back to your project, the Sputter. So what sort of state is that in now, would you say? I mean, what's your kind of commitment to it, or what's your thought about it?
I've taken it as far as I think I'm going to go. It can run a couple hundred of the Ethereum has an official test suite. It can run a couple hundred of those. It implements the persistent storage, memory. I got a little bit nuts with it and wrote a Java project that significantly outperforms big integer. For 256-bit types with numeric types, and so a lot of that stuff was good fun and good kind of wood chipping, I guess is the phrase, but I'm wood shedding rather. So I'm not
Pipe shedding, or camel shaving, or yak shaving. Yak shaving.
Yak shaving. Yeah.
We got there.
The national sport of my people. I think it's I've moved on to working on an open source project called Datopia, which is a distinct blockchain that's centered around this idea of what would happen if we embraced the immutability of blockchains, i.e. the availability of all historical values. We embrace that in the programming model. So basically, rather than submitting financial transactions, you submit database transactions. So it's basically like a permissionless multiplayer data log driven database. And it's we haven't made the testnet public yet because there's a couple of a couple of pieces of novel functionality we want to add to it before releasing it. But we've released a bunch of the auxiliary. We've been trying to sort of cut it down into components to try and encourage blockchain development in the Clojure community. So I released some of that stuff over this weekend. There's this project called Tendermint. I'm not sure if either of you are familiar with it. But it's a Go project that implements Byzantine fault-tolerant consensus or classical consensus, and offers the option of a sort of a cross-process interface over sockets. So we released a Clojure library that exposes like a sort of ring-like interface, sort of functions that take maps and return maps that interface with Tendermint. It handles all the consensus details, and your job is to just implement a sort of deterministic finite state machine that then via the magic of Tendermint is replicable across an arbitrary number of validators. So I think that may be useful for people. The project and the project itself and an example project were released today, and I hope to finish writing up a blog post about it in the coming week. We also implemented a protocol buffers 3 implementation that doesn't involve any interop or code generation. There's one project that just generates Eden maps that describe the underlying protobuf messages, and a second zero dependency project which interprets those schemas and decodes or encodes either byte arrays or streams, which is what we use in the ABCI host, which is the first project I was describing, because the wire protocol for the Tendermint stuff is protocol buffers.
So why do you think Clojure is particularly suited for these kind of things, between Sputter and the new project that you're working on?
So on the one hand, like if you asked a COBOL developer why he thought COBOL was like he would have like a watertight answer. So there is an element of subjectivity. I would say embracing immutability is great. I mean, you can run an operation, and if you don't like the results, you can walk it back, or just retain the initial value. That type of stuff was hugely useful when I was writing Sputter.
But did it change your opinion about, because when you were explaining your first look into Clojure, you said you're put off by the whole interop, the JVM thing, that is baggage that Clojure is carrying. So how did your opinion change, or if at all it changed?
It definitely changed, but it changed a long time ago. I'm still a little bit pissed off that you can't pass a string into an integer without importing or
string value of or whatever.
But I understand the trade-off, and I get that there may not be much benefit to replicating that functionality. It's ultimately all code is a liability, and just having this kind of cutesy intermediary layer, it may not be worth it. So yeah, I totally changed my mind about that after I used it more seriously and saw that what was mostly a kind of aesthetic revulsion initially for me was totally disproportionate to the abstractive powers conferred by the language, and also just the level of consideration that was put into its design is singular, I think, and pretty astonishing. I mean, not that there are things I wouldn't change about it, but yeah, I'm happiest working in Clojure for sure.
Yeah. So most of your experience in Clojure, is it web-related stuff, or did you do something with Clojure script as well, on Node or something like that?
Not really web-related stuff. Mostly like kind of asynchronous message passing, like sort of multi-stage. Multi-stage pipelines that are doing incremental transformations of some sort asynchronously.
Yeah.
And professionally, that stuff's mostly been around. Doing extremely computationally expensive and hardware accelerated stuff with on videos and compositing images. And that kind of thing. I've tried to turn as much sort of. I mean, I'm the only Clojure developer at Samsung, to my knowledge. I mean, we have Clojure, a ton of Clojure in production, but the bus factor on it is zero.
Well, one. So you're still there.
Yeah, right. Sorry, that's
0.1.
my natural pessimism coming up.
Is it because of Brexit or something, like
So are you using the the graphics acceleration stuff in Clojure, or are you just, is it just stuff? Because we had this oh man, Dragon, yes, Enter the Dragon. Sorry,
Neanderthal or something.
Neanderthal, which has all the kind of like interfaces into the
OpenCL,
the graphic accelerator stuff. So you can do all of your kind of nice matrix multiplication, etc. on the hardware level. Is that something which you're doing, or is that something else?
No, so I looked at that, and that's super cool, but it's just there wasn't really a place where we could fit it in. So most of the work that I've done has been around writing hardware accelerated FFmpeg filters. FFmpeg is it's monolithically structured, but the fact that it abstracts away so many of the the details, the codec can contain the details, makes it a really good place to embed those kinds of transformations. And then it's the project that I'm working on the moment, which is more kind of more to do with AR. We're relying quite heavily on third-party libraries that we're optimizing by shipping stuff onto the GPU, but they're mostly C++ libraries. So we couldn't. There's no real opportunity to jam in some of Dragon's wizardry there. It's less fun than it sounds.
It doesn't sound that much fun either.
No,
but you've got to pay the mortgage, so it's okay.
Yeah, or the rent in my case. I mean, also the clothes. You've
got to pay for those curtains.
So, coming back to Clojure a bit.
It's my jam.
Sorry?
I said, that's my jam.
Yeah, exactly. So, what do you think about the general documentation and the community around Clojure? Because we have been a lot of discussions these days around the features in Clojure or how they're being built, how they're being delivered.
Yeah. So on the documentation, I don't have a huge problem with it. I mean, I don't read it very often these days, except when we get like some new feature announced. I remember having a conversation with somebody who I deeply respect as a software engineer who I'd worked with previously. And he was put off just by the kind of impenetrability of the language and the documentation. I can be quite florid in my speech and writing, but I think it was recur specifically that that there was a form called recur that just killed him. I think there are some cases where Clojure I guess is specified by implementation, but some of the documentation is it's like a mixture between casual community sourced examples and then some quite formal descriptions that are very, very unlikely to be helpful to newcomers. Variadic functions isn't a term that's popular with the kids these days.
It should be.
Maybe one day, but not today.
So almost 4 years of Clojure, mostly doing all the, of course, I mean the latest project being in the Ethereum stuff. So Emacs or some other shit?
Emacs.
Okay. So tell them.
Yeah, I was a VI user for years, and it was Cider that got me to switch to Emacs, and I'm a much better Emacs user than I was a VI user. Something about it just made me want to learn. I'm sick. Like I've got my own like themes and this just like terrifyingly organized dot files. They would be used as evidence if I committed a serious crime.
So you have your mark on them.
The serial killer evidence.
Yeah, no, absolutely.
We should have known this all along.
Yeah, warning sign.
I can hear the discussion, like two agents talking about, did you get his dot files? Yes, I did. Awesome. Now let's put them on our machines. Nice. So
are you based in London, Moe?
I am, yeah.
Do you go along to the Clojure meetups there?
I don't know. I mean, I really don't like people at all.
Okay.
And it's not so much that. I just what are you going to do? Like, what library did you use this week?
No, I thought you might have been presenting something, because you've got some interesting tech there.
Yeah, I'd like to present Datopia, this blockchain that I'm working on, but I'd like to get the testnet out the door. I'd also like to appeal to your listeners. I don't know if either of you are familiar with a project called Data Hike, but my effectively the only other contributor to Datopia, which is this sort of database blockchain that we're building, is Christian Walbach, the guy behind the Replicative, or at least that's how it sounds in his incredibly authoritative Teutonic accent. Series of projects, which is quite ambitious. distributed systems approach to building distributed systems. So there's a project called the Hitchhiker Tree, I think by David Greenberg, which I would argue is so I mean it's a right optimized B plus tree. I think it's a fractal tree. I don't really see it as a distinct data structure. But it's a perfect data structure to use to maintain database indices. And Christian had this genius idea of, hey, what if we built on top of the Hitchhiker Tree and used an assemblage of trees to service data log queries, and it can do that, and it's I think it's an extremely interesting, compelling project, and that's what we use in Datopia as the underlying data store on the validators. And he recently started a PhD program in Vancouver, and I would implore the audience, if anything I've said sounds interesting to you, and you know a thing or two about databases and distributed systems, both Datopia and DataHike could do with some help.
Is Datopia is already on GitHub, or is it announced already, or are you still working on it right now?
On Datopia, so some of the peripheral stuff, like the components that'll be useful in isolation, are on GitHub. The kind of network itself is not yet on GitHub. We're just waiting on. I'm waiting on the integration of one feature that perhaps we could just talk about briefly because it's quite interesting. So I don't know if either of you how familiar either of you are with Datomic.
Yeah, reasonably familiar. Yeah.
So I've never used it, right? I mean, like in a project, but I've messed around with it. I've read the documentation. So we've sort of extended the concept of schematizing attributes, with like cardinality and type information, with the ability to attach logical constraints to them, which are themselves data log queries that are required to unify in order for a transaction, so a submission of data into the network to be considered valid.
So it's like the database procedures and the schema kind of merged into one.
Yeah, and it's all declarative. So it is just a data structure describing a schema describing a logical logic program that receives a bunch of inputs, the state prior to the block, the data in the transaction in isolation, and so on, and has an opportunity to figure out whether it makes sense. The reason why this is interesting is, if you build a network that only allows you to execute data log queries in a kind of distributed manner, so let's take a step back. That allows you to insert arbitrary structured data, and also validate that data using these logical invariants. You can build something like sound value transfer, just like Bitcoin and Ethereum have. But you wouldn't need to embed it into the core design of the system. You could just deploy an attribute that has a sufficient, we've already written up the constraints for value transfer. So that idea of you know, I hoped I wasn't going to say decomplecting, but
you failed.
yeah, no, the story of my life. So I think it's a particularly elegant design that even something that's considered you know, intrinsic. I mean, say it's basically the only thing Bitcoin can do. But you know, so something that's often special cased in these networks, we can just implement as a logical invariant over a you know, a selection of attributes that are defined in the Genesis block.
So how do you deal with, because one of the problems with blockchains in general is, you know, finality, ordering, those kind of things. So in Datomic's case, and in cases like Hyperledger, there is a sort of central ordering system. And in the blockchain, the ordering is more, let's say, consensus based. So how do you, in your environment, how do you deal with like sequencing, ordering, making sure that things are, you know, that the value is transferred in the right sequence? Because obviously that's important in any transfer of value.
Yeah, so Tendermint deals with the actual serialization. I mean, in the sense of ordering of the transactions in the blocks, and we just process them as we receive them.
Oh, okay.
And if we've already accepted a transaction, which you know, has created conditions for which this you know, subsequent transaction can no longer succeed, then we reject that transaction.
Okay.
And then the other interesting part of it is we disseminate in segments of these index structures over a peer-to-peer network, either DAT or which is a project I'd suggest you guys check out. It's not really enclosure, but it's called DAT, or BitTorrent. So we get the same kind of read scalability as Datomic, in that a client starts out with, you know, maybe a single trusted root hash. It issues a query, and it has a data log query engine. You know, it notices, hey, you know, I ought to retrieve this segment from the, you know, peer-to-peer index segment distribution mechanism, and then eventually ends up with a, you know, a fully authenticated but, you know, subset of the entire database state that only contains the data that is required to service the queries that user is issued. Rather than every network participant having to
That's impressive.
replicate the state.
Yeah.
Nice. Okay, so we're almost 1 hour. Any other?
And we're all still awake.
Of course. Bitcoin is.
I definitely thought VJ had gone at one point, to be honest. You know.
Yeah, it was looking dicey.
I'm just shaking, nodding my head, and then blockchain. Okay, moving on. So I remember looking at DataHike some time ago, but it is not a full replacement for Datomic, right? It is mostly like a single machine sort of thing, or is it the scalability thing?
Yeah, no. So it is. You know, it doesn't cover the same use cases as Datomic. It may be worth thinking about it more like something like DataScript, but you know, the fact that you can trivially replicate these indices in the manner I just described, you know, allows it to be, you know, multiplayer and authentic, and it is authenticated, like it's a you know, it's a Merkleized data structure. So it's, you know, recursively cryptographically hashed and so on. So I think it's an immensely powerful building block for distributed systems. Even though, and you know, you could even though we're not planning on doing it for Datopia, you could certainly use schemes where the state was sharded in a particular way. But we're just going to require that all validators maintain the entire state in a local data hike instance.
Okay.
So you're thinking about re-implementing Git on top of it?
You know, there's we got a lot of quite abstract comments in our Telegram channel, and one was that you know we should commit the code to
on the data hike.
yeah. Otherwise, what's the point?
Yeah. Well, I mean, you know, that's beautiful, you know.
But yeah, I mean, you know, this stuff isn't really too different to Git.
No, I get it. Yeah, it was a sort of joking point, but you know, one of these days, you know, the concept of, you know, building, because it's like Git is one of these things which again started off as a very nice sort of decentralized concept, but has ended up in kind of bit ridiculously end up in the hands of Microsoft.
Yeah.
You know, and all your code are belong to us now. So it's like, Jesus, you know, nice one, Linus, you know. It's like, it's kind of,
sure.
the sort of irony there is quite, you know, long-winded, I guess. You know, in the end,
Yeah,
like,
no, it is.
all the operating systems belong to Linus, but all the code belongs to Bill. You know, so it's like...
First is tragedy, then is farce.
Yeah.
So, but just I just on just one last point about because you made a joke about the use of the network. Look at something like DBpedia, right? So that's you know, a semantic export of you know, the data that's contained in Wikipedia in the form of RDF triples,
Yeah.
or consider any large scale data collection effort. So DBpedia is basically a bunch of gzip tar files, right? It's not a database.
It's ridiculous. Yeah.
Just imagine how many, you know, balkanized AWS accounts that data has been instantiated into, and because of a lack of strong, you know, identity, these people can't collaborate on deployments, even if they've got no intention to change the data. If you're really lucky, you'll get a rate limited API or a paid API, and I would argue that the overwhelming majority, anecdotally, of backend development basically consists of mediating access to a database to clients.
Yep.
Our idea is that that data should just be schematized and put in this single global replicable database. It would work for stuff like DBpedia. It would work for you know, experimental data from
I guess all kinds of public data sets from government and stuff like that.
Yeah, so we would seed it with, I mean, there's a ton of amazing data sets we would seed it for, and we would want to pitch it as well to you know, people who were interested in taking a more kind of open approach to science, and being able to authenticate the intermediate results that go into producing the papers.
So I know we're kind of like, you know, running a bit late now, but just one final question is like, how would you compare that to, maybe we're getting a bit blockchain. Well, it's a blockchain show, so fuck it. If you're still here, you won't mind this question. So how would you compare the Datopia stuff to IPFS?
So
sorry,
you know,
you're sighing there. It doesn't sound good.
No. So I'm not an expert in IPFS, and I've read some you know, quite compelling bearish cases on the idea that block storage is ever going to be that a permissionless network will ever be able to compete on price. That there are game theoretic reasons why that's impossible, given something like S3. but I'm like I said, I'm not an expert in it. So I would say the main difference is structure.
Right.
I mean, we and we even talked about using IPFS as the index distribution mechanism, rather than something like BitTorrent. But the point is this can do everything Datomic can do, right? It's a structured inferential database. It's not S3.
Right. So you could say IPFS is a bit more like S3, or a bit more like it's a kind of medium for you to store stuff, rather than as a kind of where what you're doing is putting essentially kind of like facilities and affordances on top of that. Storage for the storage capabilities of any kind of file system, essentially.
Yeah, absolutely. I mean, it is just a database, right? I think the ability to query and forgive me for saying this, potentially synergize.
Oh God, no! Okay. Stop the recording. We're all triggered.
This may be a little bit optimistic, but through collaborative schematization and so on, you could have different organizations structuring common bits of their data in similar ways. And I think that out there is aside from NGOs that are collecting data, universities that are running experiments, projects like DBpedia, corporations are generating a ton of non-competitive, non-identifying information that they just can't afford to release, because it means they're going to have to hire a bunch of developers to build an API, or they're going to have to shit out some tar files, every month, which is no fun.
So you think basically, Moe, you can make the world a better place?
I have an acute ear for patronization, but no, I don't.
Joking.
But
Okay.
I think I could make the world. We could make the world a more convenient place.
All right, that's good. Yeah.
I suspect the gentleman that I'm working with thinks that we can make the world a better place.
Right.
But I'm just interested in building a database that has useful information in it.
All right, cool.
Nice.
No, it's really good. It sounds like a really interesting project, actually. I'll definitely be having a look at it, and like you said, hopefully the listeners will as well. It sounds really good.
And by the way,
good work, mate. Yeah.
Datopia.io. There's
awesome.
not much there, but what's there is good.
Datopia.io.
Cool.
Okay.
Yeah.
All right. Thank you both for your time. I appreciate it.
Yeah, of course. And thanks a lot for joining us and giving us insight into all this new tech that at least I'm not familiar with.
I hope that's what I did.
You did. That was really good fun.
Course,
Thank you very much. Really appreciate it. Yeah.
By the way, we have an event called Dutch Closure Day. It's a one-day free conference about closure in Amsterdam. It's on April 6th. So if you want to join and then present, it'll be super awesome. By the time if you have
Amsterdam's great. So
yeah.
I'll totally keep that in mind. The weather ought to be decent in April.
Yeah, of course. It's going to be really nice. I think it's usually springtime, and it's a just one day conference, totally indie sort of conference. So it'll be amazing if you want to join us and talk about Datopia and other things that you're working on. That'll be great.
Excellent.
Yeah. So that's it from
one last
us,
thing though,
yes.
VJ, before we go, I want to just give a quick shout out to some of the awesome Patreon characters that are helping us out. And I'll just give the most recent batch. We try and do just like 4 or 5 an episode, and we've got 4 here. So I want to shout out our gratitude to Luban Manilov. Thank you very much, Luban. And then next is Dmitry Palamarchuk, I think it is. I think I got Dimitri right. The second bit I'm not so sure about. The next guy is Johnny Eradus. Now, it could be Eradus, but I'm pretty sure that Johnny is correct. So, and then the final one is a previous guest of ours, Mr. Daniel Compton, who's doing the Closurists together.
Yeah, and also
he's a solid guy.
He's a totally awesome bloke, you know. And in the end, what we're thinking is that whatever kind of remains we have from the Patreon sponsorship, we will actually put it into the Closurists Together pot, because, you know, that's the best, most effective use of the money, I think.
Yeah.
So if you want to join us on a Patreon, then obviously we'll cover our cost. We'll keep going with the podcast. You know, we don't take anything out of it. And like I say, we will donate the remnants into Closurists Together. So I really appreciate Daniel making that contribution. And it will definitely be repaid. Not to him as well, but to the Closure community.
Yes.
So that's thank you very much again to the Patreon people, and you can go to patreon.com/defen anytime and chip in a few quid. It's always good to have a kind of sustained volume of income to help us out. Thank you very much for that.
That's it from us. So thanks a lot, Mo, again, and hopefully some of you listeners, I think we will see you at Dutch Closure Day or at some other event. Bye-bye.
All right, thank you for having me.
Definitely burn some ETH.
Yeah.
Release some gas.
That's a good one.